After centuries of technological progress, we have figured out a computer algorithm that can actually learn.
Using human feedback to properly align with our values.
They work for reasons we don't fully understand, and they're important.
In the history of AI, around 1980, there was a fork in the road. Prior to 1980, the main way to develop AI was to program it, rule by rule. You can get intelligent behavior, and not only that, you knew exactly how the AI was behaving and why it was behaving that way. Then around 1980, there was this breakthrough. It was the hot new idea, which was machine learning and neural networks. What if we didn't have to program the rules? What if the AI could learn the rules for themselves?
After decades, centuries of scientific and technological progress, we have figured out a computer algorithm that can really, truly, no tricks, no sleight of hand, it can actually learn.
Fast forward till today, and basically everybody has forgotten about that old way of doing it, where you programmed in the rules, and almost everybody is doing machine learning. The important point here is to remember that there is more than one way to teach an AI. And the way that we're doing it right now has some really great things, like they can learn really fast, but the downside is we have no idea how they work, and they could surprise us, and that could be incredibly dangerous.
Because we can't explain today how these algorithms work mathematically, we don't understand quite why these systems work so well. It creates the possibility that these will be systems where they work for reasons we don't fully understand, and they're important.
The old way was too slow, too cumbersome. We couldn't get enough knowledge programmed into them, but at least we knew what they were doing. Is there a way to put both of these things together? Yes. Take a brief tangent with me. How do humans learn? You learn to drive a car. In the beginning, it's laborious, step by step. Fast forward a few months or a year, and you're driving and listening to the radio at the same time and carrying on a conversation, and it's almost like the driving's on automatic. How does that happen? Well, cognitive psychologists call that the proceduralization of knowledge. You've tried lots of different things, you found something that works, and it gets chunked up into a routine that then gets stored in the brain, and when you need to do it, you just pull it out and you do it. You just execute what you've done 1,000 times before. That notion of proceduralization works for any type of problem solving, and it comes from the old school. The old school AI systems used to do that. The new school doesn't do that at all. What we need is a blend of the new school and the old school, and then you can apply this kind of learning. So as these AI agents and human problem solvers run into problems, they will store all their solution attempts, and over time it builds up a library of these things. It's able to solve more and more problems without having to reason its way through it and come up with a different answer every time. And this is actually what humans do. So it's time tested. Millions of years of human evolution have shown that this approach works. And even though the neural network approach works, in all the hoopla and excitement about machine learning, we've forgotten this other aspect. We have to bring that back in order to have safe AI. A key piece of that is recording the solution attempts and storing the successful ones. Now, how do we make AGI networks safe? What kind of checks or mechanisms or features are designed into this AGI network approach that makes it so safe? Well, check out the next episode to find out.